In this interview, I speak with Pablo Molina, who is the CTO, VP of Product, and Chairman of Avidbots. I was excited to speak to Pablo and learn more about how robots are used in large-scale cleaning. We talked about the challenges they face, focusing on a strong ROI for customers, and great but relatively unknown opportunities in robotics. I'm Audro Nash. This is the Sense Think Act podcast. Thank you to our founding sponsor, Open Robotics. And now, here's my conversation with Pablo Molina. Hi, Pablo. Would you introduce yourself?
Hello. Hi there. My name is Pablo Molina. I'm the CTO, VP of Product, and Chairman of Avidbots.
Mm-hmm. And what do you guys do at Avidbots?
Avidbots, we basically, our vision is to bring robots to everyday life, to expand human potential with a hyper focus on cleaning. So we make Neo, the world's best self-driving floor scrubber. So this is basically a cleaning robot for large spaces, such as malls, grocery stores, airports, that kind of warehouse, larger spaces, basically.
Gotcha. How many square feet is large generally? So I mean, like airports and things. Like I don't know how large would that be?
We do have some, robots that work in really, really large places. We have some really exciting warehouses that are, I would say, north of 1 million square feet, 1.5 maybe. And it's just, you can basically not even see the end. You look down to the west and it just keeps going. So yeah, a very, very large warehouses.
Tell me a bit about your cleaning robots. What do they look like? How do they work?
Yeah, so Neo is the robot that we make. It's basically a large floor scrubber. So this is a machine that has a 24-inch cleaning head up to 32-inch cleaning head. It's about a meter and a half long, meter tall. Um, because we designed it as a robot from the beginning, it is, I would say, one of the most compact machines with the longest runtime. So it has basically 120 liters of water, and it can run for 5 to 6 hours. We also made it so that you can swap the batteries very easily. That's something that no other scrubber has. So you can basically, in 15 minutes, just put more water, swap the batteries, and then you can run another 6 hours. We have people using them sometimes up to 18 and like 12 hours straight in some malls, actually. And the robot just keeps cleaning the entire mall. So yeah, that's definitely an advantage of how we designed it. Also, yeah, I will say in the industry, it is the most, I guess, really the most well designed from a point of view of autonomy. It has a full 360 view, LIDARs in each corner. It also has 270-degree 3D cameras, so it's able to see anywhere it wants to move, and therefore is very safe. It can operate in very cluttered environments, like a grocery store with all these different things sticking out, and is able to pick them up and avoid them properly, which is really important. So the LIDARs, we have two LIDARs, one in each corner. So it's a 270-degree in each corner. So this is a pretty standard thing in AMRs that you see like a LIDAR in each corner for full 360. So yeah, but then we also have three 3D cameras, four actually, two in the front and in the sides here, and a bit like the ears, I guess, of it. And so it's able to see all around. So when it swings to the right or to the left, it's able to see before it turns into that area. Yeah, so it's something that it's not common in the industry. A lot of robots just have sensors at the front, and then when they swing, sometimes they impact things and they collide. I guess the other thing is, yeah, the other, last but not least, is the whole. It is also a multi-application robot from design. So we actually have an add-on, as we call it, a disinfection add-on. So you strap basically this water tank at the back of the robot with a disinfection gun, and then the robot can basically disinfect as well. So it's cleaning and then also disinfecting the facility as it's driving by. And that's something that we're really, exactly, it's chemical disinfection. Yeah, yeah, exactly. Yeah, so that's it is something we're really excited about of the future, like where that might go, with what else we can make it do as part of the platform.
Yeah, for sure. And I imagine there's a lot of challenges with this. I mean, but so first, I mean, I've looked at some of the pictures. To me, it looks like a big cart in a sense, like one of the ones you'll see in an airport that someone rides around on that cleans the floors. Um, is this? Would you say this is kind of a fair description of it for this? And you have the little cleaning thing in the back.
Absolutely, you got it 100%. Is the main that we replace is called, I guess, the Tenant T7. Tenant is all over in North America and is a green one, and people drive it. And of course, those are bigger. Neo is actually, again, it can run 6 hours, but it's actually kind of a very compact, slightly more compact version of it. And yes, because it's a robot, it doesn't have a seat. It doesn't. It is. I would say Neo is not. You can drive it by hand. You can definitely clean by hand, but it's not as comfortable. It's definitely more of an autonomous robot. So we took the decision to make it. Yeah, you can. Yeah, it's just you cannot see in the front, so it's a little bit tricky. You have to kind of go to the side a bit. So it is awkward to clean by hand. We're not gonna disagree on that, but
So it's not really. It's not the intended use case. You can if you're in a pinch.
that's right. Yeah.
Gotcha. Now, one thing that I thought was really clever, and I'm interested to see why you didn't go this route. So there's the company Greensy, and they do autonomous mowers. And they one of their goals was to make it so that they could have a person jump on the robot and also do lawn mowing with it, just like they would. It was basically the robot was totally out of the way. And the nice part with this is you can have the people do the stuff that is really difficult and you haven't solved quite yet. And you can also, like, and maybe it's specific to mowing, maybe your environments are a bit more controlled or something like this. But why go the full autonomy route and not try to have like the human riding along or doing the difficult spots? Even like what Greensy does is they do the edges and then the robot fills in the middle, which is the really repetitive part that the robot can actually do very well. Why why choose the full autonomy approach?
That's interesting to hear about that company. That's cool. Um, so again, so the environments that we operate oftentimes are very tight, right? So you do have the 6 foot aisles that have 6 foot endings, sometimes 5 feet endings. So the length of the machine becomes really important. So a lot of the competitors that we compete against, they have transformed basically a manual machine into a robot. They added a bunch of sensors, but it's still a manual machine. So yeah, there is a lot of volume that the human needs to use, and so the machine that ends up being wider and longer. Length really matters actually when you're trying to do those very tight turns, those U turns, exactly, and also to get closer to edges when you're trying to navigate into an edge. The length really matters. It takes you longer to get closer to the edge if you're very long. So that half a meter actually makes a big difference. Our robot is a lot more compact. Theirs is longer. That was one thing. Also, I mean, we did try actually, to be honest, as a startup at the beginning. We did see if there was appetite for the other cleaning companies to collaborate with us, and we just sort of connected it. But again, we didn't succeed there. We decided to then make our own, and I do think it really has helped us a lot from a navigation point of view and a sensor placement point of view as well, modifying the manual machines to really make sure it's good sensor placement. The same also for the battery changing. So again, and I guess in cleaning, we basically stay about 30 centimeters from the edge. It is something we want to improve. It is something that we're working on, but it's oftentimes good enough in a lot of these facilities.
Why do you stay 30 centimeter 30 centimeters, so about a foot from the edge?
Yeah. Yeah, so it is actually, it's very, if you can think about it, it's actually a super beautiful problem. Like so first of all, getting a big machine to get close to the edge. Even today, by the way, when people clean stores, they don't, the big scrubbers, the big dry ones, they don't get very close to the edge because yeah, humans can make mistakes. They can collide with things at high speed. Also, it's just difficult because of the length. Like you're trying to like angle it in, and oftentimes you leave a lot of areas uncovered when you're getting into a turn or into a edge. So a lot of the times people still they go with a mop and a bucket, and then they basically clean the edges. That's still how it works today. And so it is, yeah, but it's a super challenging robotics problem. It's very interesting, the interplay between autonomy and safety. Like, how do you do this safely? There's a lot of complexity there. So we're definitely working on that as we release our new products. It's something that we're definitely working on and wanting to improve.
Yeah. So I imagine there's a lot of hard problems that you've encountered in this space. I'm thinking the foremost one to me is mapping the whole space and everything, because I mean, I just like 1,000,000 feet seems like a very big map to maintain. Um, but would you tell me a bit about the major challenges that you've had with this robot?
Yeah, for sure. It's basically. I think you're definitely in the right avenues. It's a very. I still remember the beginning thinking it's going to be easy, but it's definitely not. There's quite a bit going on here. So of course, starting for localization, I will say really our robot is operating in a very dynamic, unstructured environment, and so localization is definitely a big challenge. As the map is constantly changing, how is the robot able to maintain its position and update its internal map? It's been something we've been working on for many years. We're getting a lot better now. Also, we you might know that in some warehouses there's this idea of a bulk warehouse where basically it's kind of like a temporary storage. So they drop some material and then they move it basically in like a few days. So the map is changing like super frequently. So that yeah, definitely super interesting challenges in localization. The other piece certainly that we've invested a lot in is super interesting problem is the coverage problem. So a bit what you described, the mapping that you were mentioning. So mapping, we actually map by hand. We have a deployment technician that maps. In some of these warehouses that are 1,000,000 square feet, yeah, the good thing is that they are very symmetrical. So sometimes you can copy the map over. You don't have to map every single aisle if the architectural diagram is very similar. So of course you cannot just like copy the CAD diagram and put it in the robot map. That doesn't work. But you can still you map most of the big areas and you still are able to reduce some of the work by leveraging the symmetry of the building and the way that the aisles and the shelves are laid out. Exactly. So there's that, but the coverage problem though is super interesting.
Yes, I want to talk about that too. But just so for the mapping, what do you do? You have a guy with like a LIDAR on a stick or a few cameras on a stick and they walk around it, or what does it look like for you to generate your maps?
We do it like a lot of other AMR companies. Like we will ship you the robot, and then we send a deployment technician, and the deployment technician has about 1 to 3 days that he's on the site, and so he's mapping the site, and then uploads this map, and then our team is able to work and create basically what we call a cleaning plan. So it's exactly how the robot is going to clean your space, and is able to configure to your liking. Like if you would like in some malls they like to clean the entrance twice, or maybe with more water, maybe in the winter because there's salt and things like that. So we really like this ability to configure with you your cleaning plan so that it really solves the problems that you need, and it is really tailored to exactly how you clean and how you wanted it to clean. And so yeah, we map by pushing our robot around. Robot already has 3D cameras and lidars, and so it's able to. Yeah, that's right. That's right.
Makes sense. And then you get all that data, you build a big map. And then once you have that map, how does it work when things change? So when you have that, what did you call it? The temporary thing that in warehouses they'll bring and they'll put a bunch of things into one area, the dump places, and then move it out in a few days. How does it work with that from a mapping perspective? Do you just say these are the edges and everything in between is chaos, and you'll just figure it out and try to connect everything as best you can, or what do you do?
Yeah, that's a great question. I think it's like two questions in one. So one thing is, so the way we clean is we call it we call it a cleaning plan, and then we draw these rectangles that we call them sectors. So the way a robot cleans is it remaps a sector and then it replans the sector dynamically. So that's actually a big differentiator of Avidbots versus our competitors. Like our robot is constantly replanning the route to be as efficient as you can. So imagine if you put like a chair or a table or anything in the cleaning area, then it will dynamically plan the most optimal way to clean it. And then also in the same time is what you were asking about. If the map has changed drastically, the robot has a start position, so it knows where it is. So it is running a kind of a SLAM algorithm in a way, and it's basically updating its internal map and basically correcting for sort of the big changes if there has been any big changes. And yeah, of course, if the map has changed too much, then of course we have safety systems that detect it and we stop the robot. Or we also have by the way, another big thing of Avidbots is we have a 24/7 remote assistance system. So we have a team basically able to jump in. So if you have a major localization failure, we don't like to bother the customer unless indeed it's really, really, really bad, right? And so a lot of the times, the human is able to be like, oh, actually, no, you're not here, you're actually here. And is able to, there's some really hard localization things that humans have a very good ability at solving. And so, yeah, we are firm believers that, that you can getting to 99% autonomy will happen. We will get there. But until we get there, the customer experience is extremely important. And we don't want to be, and also a customer can never go to a robot, be like, your localization system is wrong. Let me tell you where you are. Like you almost need like a bird's eye view, right? And so it really helps to have a remote person with the right tools and the right knowledge that are able to correct that. So that's something we provide with every robot. So our promise to customers is you press play and it goes. And so
It's like a big
rescue.
Roomba, basically.
Yeah, exactly. Yeah.
One thing that strikes me with this, I mean, I have a few questions all from this, but how does connectivity work? Like you're in a big warehouse. Do you have nodes for wireless like bumpers everywhere so that you can keep the network going? Or like I assume you go out of network sometimes and have connectivity issues. And then in this case, the robot can be stranded in a spot where there's no ability to call for assistance. Or do you make sure that you are always connected?
Yeah, that's a wonderful question. So yeah, we really like to be always connected. It's something we really try. A lot of the customers we work with have Wi-Fi in these warehouses, and we work with the IT team and we get into the Wi-Fi. Our robot uses very few ports and is very safe, so we're able to convince them most of the times. Sometimes we're not, and they don't let us in. So then we do use cellular connection. You're right. A lot of remote warehouses is tricky. It's tricky because like in some warehouse, like half the warehouse AT&T is really good, and the other half Verizon is very good. So it's annoying
two SIM cards
sometimes.
in your robot.
Oh, no, I'm kidding. Well, it's funny though how sometimes that happens. But yeah, so you're right. And then we do have then of course I would say our autonomy average for the whole fleet is like in the 87% plus. So we can also make the robot able to just make his own decisions, but it's not something that we do think it's better to have connectivity. So we really push for that because it's really important to ensure a really good experience. And yes, I hope as we all get better and as our autonomy gets better, it can get to the day where it's like 99% and then it's ready to be by itself. But again, his experience is what really matters.
But even 99%, for sure, even 99%, if you have like tons of these deployed, you're going to get in that 1% all the time. And I don't know, then you need the human still. It's just, I'm seeing that it's very hard to solve every edge case. And so it's like a constant game of catching up to the novel like little tail events that occur.
If I could tell you the amount it's unbelievable. Like the kind of corner cases, like when we have any issue, it's like like 4 things went wrong for this to happen, right? It's like, wow, like it's a very interesting, like this one thing happened, then this thing happened. Like then you went into an elevator area and then this happened.
Do you have any
um,
specific examples you could share?
like I guess I would say a lot of the issues are like 3D cameras, for example. I cannot. I mean, I can be upfront about it. We do use like the basically D435. So this is a stereo camera. Yeah, Intel Realsense. Yeah, so you're probably familiar. It's yeah. I think we're a very good customer of Intel. We give them a lot of feedback of and this is why again we have this obsession with data. Like we do care about the productivity and the things are going well. So we share a lot of data with them. So it's amazing to see like what makes the camera fail and how, and things that you wouldn't normally expect, like this very weird mesh or this pattern in the wall that's just at the right angle, or the sunlight that's coming just at the right angle. Also, if say that you're cleaning an environment that's a little bit warmer, and then your motor controllers are a little bit in the warm side, and then you're trying to go up a ramp that's like maybe 3-4%, and then that's what I mean. So you have to be warm, go approach a ramp, try and turn in a ramp. So an obstacle has to be in a ramp in a warm place for then the motor controller to fail and the robot to stop safely, of course. But it's just funny how like it's like how did that? Okay, so that's great. So many things have to go wrong, and but still. So you're right. There's 90. I think you're totally right in that as we grow and as it expands, it will never really go away. We believe we always want to keep this connection with the customer and this ability to help if we can, and it's just very important, and it gives us the data to improve. I mean, I think that's really what is the goal. So it's been tremendously helpful to keep getting better and to have a pulse on what's happening in the fleet, right? To have all this data.
For the Intel Realsense, I was working with them at some point in an internship, and I vaguely remember, and I may be wrong, but I thought they did a lot of clever tricks to infer 3D information about the scene. So like they are stereo, but the baseline between the two cameras is actually pretty small, and they also do something where they emit some sort of infrared pattern that they use to infer that it's 3D. But like they combine those two tricks because generally you want like a wide baseline and then you can infer a lot, or you can project a very nice, good pattern on things and you can infer a lot from that. But they kind of like do a little bit towards both. They have a small baseline and they project a pattern that maybe isn't as easy to infer the 3D information from. And so I could imagine that being tricked pretty regularly in production. Um, how did you choose to go with them, or like how did you choose Intel over anything else versus like a wide baseline or any other? How did you choose that sensor set?
Yeah, it's a great question. If you came to Avidbots, it's pretty hilarious. I think you'll see all of our robots, and I think we pretty much have every 3D camera ever made that could possibly be used on a robot. You will see like the Kinect V1, then the Kinect V2, then 5 different versions of time of flight cameras, and then we were very sad when the like Apple acquired the company that was making the Kinect V1, and then they canceled the open source drivers and stuff. So we've been very close to all that action, and again, a lot of people are like, yeah, perfect sensor is awesome, this and that. We buy it, we try it, we break it pretty quick. So we've gotten pretty good at breaking through the sensors. So I'll say, yeah, Intel certainly, I agree with you, it's not perfect by any means. It's a sensor that I do have to give them kudos to them for the price point and what it is. I mean, it's a global triggered 2 devices with a projector. Yes, low power. That's maybe the biggest flaw, is it has such a low power. But it is for the price point.
Is it Why is that a flaw to have low power?
Yeah, that's a great question. I can talk about it for a long time. I wonder if Intel will be okay with me going that deep, but but it's okay. I guess so. The basically. Yeah, so I mean, Intel interest in this camera is okay. Let me answer your question first. So when you have again, because we're in the real world, and because we get to clean an airport where there's a giant window in Singapore, and there's the sun, the equatorial sun, really strong midday. and through a glass window that doesn't have the standards that we have here in North America, where you have this very thick, IR filtered glass. You have this glass that it's just like, yeah, very simple glass. So the sunlight goes right through, right onto this beautifully shiny, perfectly waxed floor. Because Singapore is a great country with a lot of money, so they have these beautiful floors, and yeah, so the entire area is basically flooded by IR light, which is right on the frequency of the emitter. So what happens is, you're right, they use the stereo correspondence, a very traditional algorithm, but they get around the lack of texture with this projector. But what happens when you have a lot of light that's completely washing it out? What ends up happening is it creates this like kind of volcano looking kind of artifacts. And it happens a lot also in warehouses, in the older warehouses with, there's these light bulbs that are not LED, they're like this incandescent, very like in the 1990s. So that also shines in the concrete and also saturates the sensors. So I think there's a lot of ways to saturate the sensor. I have seen, again, other solutions from IFM and stuff. They use similar concepts, but they do have then much bigger IR emitters and then much bigger filters in the cameras. And that seems to really go a long way. But then that increases the cost, right? So it's, it's this, that's the other thing, again, I have to say with cleaning that is very different than other AMRs. There's a lot of people out there that make like $100,000 robot, right? They can just put, 3D LIDAR and call it a day, or put like really nice, high, expensive 3D cameras, call it a day, $2,000 3D
Yeah, the
cameras.
top of the line for whatever it is.
Exactly. In cleaning, maybe for a good or a bad way, but we are from day one. It's like you have to be very picky about the bomb, very picky about why you do what you do, and so we're in this mixture. Like we're not like a Roomba, like, but we're also not a $100,000 robot. We need to be a bit like prosumer, arguably almost, and be very careful because. But actually, I think it's a very good thing. I think it's very important for the robotics industry overall, frankly, even for all of us to think more that way, right? To go more to the super low cost mass production. Because imagine if today it takes about $10,000 to make a robot, just sensors and the controllers and whatnot. If we can get that to like $1,000, that will just open up the field. Like I think it's very important that we go that way because it really will help all of us.
What do you think? I mean, like if you look at autonomous cars, they go and they buy the most expensive Valadyne LIDARs, and they'll have like, I don't know, it'll be like, I don't know how much they actually cost. Maybe it's like a $200,000 or a $500,000 or core. I don't know, some very expensive, just one sensor, and they might have three of them on it. Like living in San Francisco, I saw these cars with massive LIDAR driving around all the time. Um, they're kind of going the other way, and they're going, we are basically going to bet on this, and we think that the cost of these sensors will come down. Even like in my time in robotics, which has been like about 10 years, the real-time kinematic GPSs, which give you, I don't know, centimeter level accuracy as a GPS, have come down from like 50,000 to like a few hundred, if I remember correctly from a past interview. I think again it was Greensey. They're using the RTK GPSs, and like that in 10 years has come down incredibly. Like I'm just wondering what the argument for going as for the lower or like the cheaper products to try to build up the rather than getting more expensive ones and hoping that they come down in value or down in price.
Uh, well, I do think is a bit different. I think the autonomous car companies they have like they raise billions of dollars and they are going after $1 trillion market. I mean, I respect that. It's a tremendous. Our market is going to be probably in the high single digit billions, so it's big, but it's not $1 trillion. It's not going to be $1 trillion. Let's be honest. Let's hope one day the robotics industry is $1 trillion. That'd be awesome, but not there yet. So yeah, but we as a startup, we have to grow. We have to be profitable. We have to pay the bills and make sense of things. Also, I guess And you're right. I think, yes, there's a lot of amazing work going on solid state lidars. I think people also oversell that. There's a few lidar companies who reached out to me, like, every year I get a new email. It's like, oh yeah, we were gonna do this, but it doesn't quite work yet. So it's a work in progress. I respect the higher hustle. I can only imagine how hard it is to build a outdoor rated, it's a 250-meter range lidar, solid state lidar. That must be tremendously complicated. I do think indoor is a lot easier. I mean, we don't have IP67 requirements. We don't have long 250
That's
meter
like
range.
water and stuff, right?
Exactly. And dust, I mean, or anything like this, like fog is tremendously hard for lidars. I did work in a lidar company for a few years, so yeah, dispersion compensation is very difficult problem to solve. So yeah, they have a lot of hard things to solve. So that's the thing that I don't follow too much. I do think, yes, those guys, they're doing the right thing. They're going to come down in price in 5-10 years, and they can afford it and they can live for a while. But I guess I doubt that those sensors are gonna make it to indoor though, because those sensors are, if they do pull it up and if they are $100 a pop and they're like a nice 3D one, they still are gonna be, again, longer range. The field of views are gonna be narrower and tailored to cars, not to robots. So I am curious. I'm curious if that's really where it's gonna go. Again, and also they might be $100, but that's because people are buying hundreds of thousands of them. If you're talking buying in the thousands, is it gonna really be a few $100? So what I've actually seen in our industry, and what, sorry, yeah. So maybe if I can say that. So for example, what's happening with companies like Skydio, I think is really interesting. I don't know if you're familiar with Skydio, the drone. Probably you've heard. Oh yeah, then you should check it out. I think you're gonna love it. um, it's a, yeah, awesome company. Really, I have a lot of respect to what they do. They made a drone, and then instead of putting sonars or any sensors, they just put a bunch of cameras, and then they did deep learning, so deep stereo, and then it's incredible. This thing can drive through a forest with like these leaves hanging out and like everything, and it just drives right through, and it's just incredible to watch. We have one. We bought one. We've been playing with it. It's pretty good. It's pretty good. We even made it fly through like wires, like in the sky, and the electricity wires, and it just avoids the wires. It's unbelievable. Yeah. So you see that's I do think that's probably where our industry is going more towards. Kind of a, yeah, I think vision is in a place that's quite exciting, where what people can do with deep learning is very impressive. And it's, yeah, and again, now there's this crazy new CPUs being released as well, like the Xavier, the NVIDIA Jetson, or Ren just came out. Or Ren came out 6 months ago. Like it's like what, something 3 teraflops or something like that. It's $300, right? So it's I don't understand how this it's so exciting to be alive, and to be like, when I was a grad student, I had a 90 watt, giant dual board GPU with like an external power supply, and all it could do is like 100 giga of flops, and I was so proud. I was like, guys, check it out. I'm like the best. I'm so proud. And now it's like $300, 10 watts, and it's like 3 teraflops. And I'm just like, okay, so that's awesome, and it's probably where it's gonna go. It's just, this is so exciting, and to watch it develop like this is very, very cool.
Yeah, it is really cool. I'm blown away even the last 10 years in robotics, like how much it's changed and grown and these different approaches. So let's see. And then you mentioned earlier the problem. Actually, one question before then. So you have your maps going back to you have a big map of the facility that you're in. Then from there you have cleaning zones, which I imagine is like a little map in the map where you do sort of dynamic planning over. Um, how does that work? Because I'm imagining if you tile them, the boundaries of them would probably be weird, and so maybe you'd want to like overlap them or something like that. Um, do I understand these zones correctly, or how do these zones for doing dynamic planning work?
Yeah, so currently our sectors that we call them is basically rectangles actually. So it's kind of a bit simple, but it works actually really well. So like if you're cleaning a warehouse, you will have a rectangle for each aisle, and then you have a rectangle outside for the main kind of like the area where all of them meet. And sometimes we are actually able to then connect some of the sectors. So then it doesn't have to turn around in a U. It can go in a kind of a S pattern between different sectors like that too. That's what we do a lot in grocery stores because there's no room to turn around at the end. So we actually just connect them together, and it does a bit of like an S motion. But again, if
So you
anything has
snake down the
changed
aisles.
inside, exactly. But if anything has changed, we have what we call, so for each square, we have this little mapping run. So it goes back and forth, remapping the sector, and then it plans all the other paths to finish cleaning the sector. So it is dynamic then, so it's able to, to, yeah, basically react to change. And that's sort of how we're envisioning even the future as we move forward. We do want it to maybe not be just rectangles, maybe be different shapes, but then again, still maintain the idea of exactly remapping it and then covering everything. That's still very likely how we will proceed.
Gotcha. That's a cool thing. I think so. Now, if I understand what you do, is you have those zones, and those zones, you basically draw them on natural boundaries. So you're going to draw this one aisle, and that's a rectangle. And in theory, you could do any shape like that. It'd be funny if you get a warehouse and they organize their stuff in circles or something, for example, which would just be like a pain for this probably. But you can make it so you have arbitrary shapes, I'm sure, for these zones eventually.
We're working on that, yeah, for sure. And it's actually surprising. Not that often. There is buildings that have like a big circle, and then we just draw like 2 or 3 squares like that. Good enough. Yeah.
Yeah, for sure. Nice. Okay. And then how does the coverage problem work? So that's making sure that you clean everything, um, and you want to make sure you go back and forth and get it all, basically, kind of like a Roomba tries to cover everything.
Exactly. So yeah, then for each sector, there's also we do run like a basically a TSP, I guess, to try and we don't actually do the way a cleaner will clean. Is they will go up and then they will turn around and go back down, like a travel salesman problem. So we're trying to minimize the length of the traversal. So basically, yeah, so we don't do what a cleaner will do. A cleaner will go down and then turn around and then go back right in the same row, like right the next row, because he needs to visually see what he has done and what he has not done.
Where he
But
is.
exactly, but the robot we don't have that problem because we have localization, so we know where we are. So then instead, our robot likes to do wider arcs that are actually faster. So if you wanted to compete, okay. By the way, we don't claim we're better than the human. That's a very bold thing to say. We do say that we're like 80-90% of the speed of the human, but there might be some specific
You're
cleaning
probably
cases
cheaper than the
where
human by a pretty significant amount.
yes, we're a lot, yeah, definitely cheaper than a human. Most cases is 6-month ROI, return of investment of our product. It's actually very healthy,
Wow, that's
which is really
insane.
good. Yeah. It's important. It's very
I'm
important
impressed by
for
that.
if you clean 4 hours every night and we can automate that, it will be 6 months ROI. Yeah, which is pretty good. And we have some customers in Australia. In some jurisdictions in Australia, for example, if you clean at night, there's labor laws that require like basically almost 2.5 times pay. So cleaning professionals make about 130,000 or so a year. So it's then even a better ROI.
It's really interesting to me, those kinds of policies, because I get that they're very well intentioned, but they just incentivize automation significantly. Because now someone's going, this person is 2.5 times what I would like to pay them. And therefore, I'm looking for the first thing I can do to make that easier or less. I want to pay 1 time or less of what I expect to pay for that. It's just interesting. It like backfires.
I wonder what the macroeconomic impact is. I agree. I get why they want to, if you're somebody and it's tough to work overnight. It's well intentioned, yeah. But I don't know what the outcome is for sure. It's a bit complex. Yeah.
the outcome is either you don't clean, the person cleans one third as frequent, or then you just grab the robot to clean as quick as possible, and incentivize this development because it's a very clear market for you to get into for this kind of thing because you can do your ROI in 2 months, which is nuts, or I don't know, something close to that.
It's very good, very healthy for sure. Yeah, they end up making they're very happy customers, the Australian customers for sure. Yeah.
I bet. How so going back to kind of the problem, so you get to do longer turns because you have the or wider turns because you know where your map is, so you're not constrained to do the back and forth that a human does to know their place in the hallway or in the strip, whatever it is that they're cleaning. Um, how else do you do planning? I suppose if you have obstacles or things, that makes it a little more difficult. You have to work within the kinematics of the robot so that you don't hit anything, or try to turn more than it can. These kinds of things. What was kind of like the big challenge in this? Because you mentioned it was a big challenge.
Yeah, I think the big at the beginning we were very picky and very focused on being very close to the edges, and then yeah, again we through more customer discovery we figured out it is really about the productivity. It is really about the robot able to run at the top speed, head down in this areas and able to be close to the human. So that's really important. Uh, yeah, I would say, of course, then yeah, then we do then the plan, and then we're pretty optimal because we are able to take wider arcs and clean it very quickly. And then yeah, we do have a pretty advanced also then obstacle avoidance, so we're able to then see an obstacle and avoid it very quickly without having to stop. So we can sort of predict the speed and not really slow down to a halt and then very quickly avoid it, because yeah, as you can maybe imagine, in some really dynamic places with a lot of people, it would be quite bad if the robot had to come to a stop and then resume. Like the deceleration and acceleration takes quite a bit of time, so it uses more power and time. And humans don't do that, right? Humans, if some guy is sitting there, they're like, oh, okay, it's coming or whatever, just go around. So we do that dynamically as well, and that saves a lot of time. Um, Again, I still think coverage planning it's just such a tough problem. Like I wouldn't say that we are done solving it by any means, because yeah, like now we're going to some customers, as I was describing, bulk locations. There's some bulk locations that are what we call unstructured bulk, where there is not even the idea of an aisle. There's not even an aisle. Like it is super random, right? So not yeah, it's just then it becomes more like the Roomba, right? I think the Roomba was kind of house robots are designed for severely unstructured environments where they have to explore and then they make their own sectors and stuff like that. So that's kind of I think where we're gonna go. And yeah, so it's a I think by far not a solved problem at Avidbots. It's still something we can do better. That we can be more optimal. We can clean more kind of exploration in very difficult places. So it's certainly a very beautiful. But then that's the funny part too. A lot in robotics, like again, tremendous amount of literature work, tremendous amount of great community, but they in research they love stopping. It looks kind of solid, okay, that's it, and then they kind of move on to the next thing. But there is, as you were saying yourself, like it's very hard to do like coverage planning. A lot of the coverage planning algorithms are all for like differential driven machines without the holonomic constraints that we have, which are pretty bad actually, because this we have a tricycle robot, it's a tricycle, so it really needs to have this. It needs to have a lot of dynamic constraints, so we have to figure that out too. So there's a big step between where literature says something's done and you now actually deploying in the real world with real environments with real maps that are really complicated. I think there's quite a bit of feature depth in there. Yeah.
Yes, that's why I was thinking the maps would be such a hard problem. Because you say you do slam and generate a map and work within that map for such a big map, and then it's like, okay, now try a 1,000,000 foot warehouse. Oh, and everything's changing all the time. Like I imagine, I don't know, like on what order these grow, but I imagine that it's at least like, I don't know, like it's going to increase over, like as the map gets bigger and bigger. I think the complexity probably rises exponentially or something like this and makes it harder to maintain such a big map. But maybe there are algorithms that make it like, I don't know, linear or log n or something like this.
I guess yeah, we are lucky that it's not. I mean, we have never been to anything bigger than like 2 million square feet. 2 million is like I believe the largest we've ever cleaned. And the truth is, yeah, the fortunate thing there is that we, you know, yeah, we RAM is a thing that I think we have that people maybe 10 years ago didn't have. It is not that bad for you to go with 16 gigs of RAM and just run the whole thing like that. So you can brute force it. Although we are also working on making like tile maps so that like we're actually looking at taking elevators and stuff like that. Exactly. So you can make tiles and then just run it like that. That's kind of where we're going to be able to accommodate even more locations, even bigger and bigger. But yeah, it's I think something that this work is doable. It's not that hard.
For sure. Yeah. Yeah, I imagine tiling is a good approach. I can't intuitively understand why tiling would be bad, other than you don't know where you enter the next map over. But or maybe overlay the maps a little bit so that you can have a little bit of cross between it, and then you just maintain two instances of ideas of where you are in a map as you segue from one tile to the next tile. This kind of thing.
Yeah, there will be some interesting parts. Like if maps have changed a lot, that might be hard to do as well. Like if you're updating the map in the one tile and you switch to the next, that's the one that we're mostly concerned with because it might have changed and then your current the entry point might not be correct, might or might not be correct. So there's some nuances there for sure. Yeah.
For sure. I wonder, though, the way you're doing those segments, the zones now, if you were to tile on like kind of known zones where it makes sense, like this won't move most likely, and we can say it's here, and then like you manually, because it sounds like the zones now are manually configured when you generate the map. You say, okay, here's one, we're going to plan a cleaning path in that. Here's another, we're going to plan it there. But those are kind of like features in the map that lend themselves to being zones, and I wonder if the same kind of thing would be true for tiles.
Yeah, I mean, again, today we can handle like we can handle like almost 2 million square feet, but I do think yeah, tiles is a thing of the future. It's how we're gonna do when we do buildings, when we do like different levels. That's gonna be a requirement. The robots gonna have to get in the elevator and up in a different map. So that's gonna happen. You're totally right. The yeah, I mean today it is manual. Today the technicians upload the map and we manually draw that. But we are planning to, yeah, we're working on algorithms to make that really, really easy so that the deployment technician or even the customer can just kind of draw the sectors like themselves. So they will draw a big, here's the map, and they will draw a big square, and then the algorithm will detect the edges, and then it will create the sectors by itself. We're working on that. It's not as hard as it's not that bad. We thought it was going to be harder. It's actually we're doing research on that. We're doing research on that, and because again, that's kind of how if you look at the latest, it's quite impressive by the way. The iRobot S9 Plus and the Roborock Ultra 7 SB7, they're amazing. Like they explore your files and then they dynamically sector themselves. It's amazing, and I a lot of respect to them. We had a little to catch up to do there, but we're better in some things, but they're certainly better in a lot of others. So, but yeah, again, different use case, but quite impressive to watch the years and years of R&D.
For sure. Yeah, we have one of those J7s or whatever it is, Roombas, and it's fantastic. It also has the poop detection, which is funny and I think very useful. We're thinking of getting a dog, but like what a hilarious thing.
Yeah, we're also working on that as well ourselves. We're doing semantic segmentation. Our problem is forklift forks. So we have these forks that are
Oh, those are always so
very
tricky.
yeah. So
I
we're doing
consistently hear that those are incredibly painful and tough to detect. You don't know if they're
uh,
down or up or whatever,
exactly.
so you
So
can run into
that's
them.
But yeah, and then yeah, we have an
And they're thin
algorithm.
too.
And I would love to show you. It's so funny. Like there's this spatula ones too, which is like they're literally like a spatula. So they're right against the floor. They're very wide and they're very shiny. It's just like, man, this looks like water in the floor. Like if I'm a human and I'm looking at that, I'm like, is that really a forklift fork? Okay, I guess it is. So it's yeah, we have to. Deep learning is the only thing that can come anywhere near to solve that problem. So and it's working really well actually. So that's what I'm saying. I think that's really where this is all going to go. It's all going to be deep learning based training. Skydio is doing forests and wires. iRobot is doing the obstacle detection, the food detection, and so yeah, it's I think it's definitely where the industry is heading. I wonder, I guess, yeah, how it will go with Intel and the cameras and stuff like that. So let's see.
Hmm. Yeah, it's an interesting thing. The challenge changes with all the deep learning things because to me, then it becomes about getting all your edge cases, um, which then kind of it's like they're constantly updating when they're finding new things, which is really interesting. A recent interview that was just published was with Alcatraz AI, and they do access control. And hearing about like if a person who is carrying a backpack on the back and the front comes in and their camera sees it, it's like it might behave a little unexpectedly. So then after that, they go and hire an actor, and then they go try to generate the data with the actor. It's just it changes the whole nature of the problem, which is very interesting. I don't know. But then it lets you solve a lot of problems like this, like the forklift that you were not really able to do before. I
Yeah.
don't know. It's an
That
interesting thing.
contextual
I'm
understanding
curious,
is
and I
very.
think,
Sorry. So I was just gonna add, yeah, like contextual understanding is really important. Like be able to train the algorithm that this belongs to a forklift and it sees the forklift and therefore it has forks, or like is a whiteboard that has those weird legs that stick out, or the ivy pole. It's all is that basically is the way of why we understand it, and so it's I don't think there's any chance of any sensor really, any 3D camera or even 3D lidars. Like it's too small. It's in the realm of centimeters, right? So it is really something that vision is basically the.
lends itself to. Yeah, yeah, it is amazing. I do think there's a lot of power in vision sensors. Like LIDARs and things are very cool, but and people give them a lot of flack. But like Tesla with their cars driving using mostly vision based, like it's pretty amazing what they can do. I rented one a little bit ago and was just blown away by I like slowly gave it more and more control as I was trying it because I mean being in robotics you hear all the like horror stories and kind of understand how they're doing things and it's but I was tremendously impressed through it. And it's all vision based. It's a very clever approach. And I mean we clearly are evidence that vision seems to be a good sensor for doing a lot of things in the world. Um, it's cool to see you guys going down that.
Yeah, the regulation of space and outdoor is gonna get really interesting. A lot of people are saying maybe lidars has to be there. There's a lot of debates on camera versus lidar, but again, what you said is definitely the case. Like indoor is so much easier, right? So in indoor, from a safety perspective, we can just stop, right? If the robot is not working, we stop. We don't hurt anyone. A car cannot just stop. Car has to park by itself, and there's a lot more nuance and complexity, and again fog and all these other things, and so we have it a lot easier. So I do think if vision has a chance, it's definitely going to be in AMR industry a lot more than like outdoor cars. Yeah, let's see how it goes. Let's see who wins that big argument.
Yeah, it's true. I wonder. The one thing that's really interesting with Tesla is they have so much data from just everyone who has their system and it's being uploaded. It's like they have, I don't even know, but it's probably like a million times more than like GM or something like this, like Cruise and all these. But I don't know. It'll be interesting to see because I mean all of the sensors versus just vision and this kind of thing. And then yeah, in the indoor context, it certainly is easier to use vision. How are you generating your own data for? Are you just like you take a forklift, you move it, you position it, you wait till the light changes? Or are you guys doing anything in like simulation, or how are you generating all the data for your these perception tasks?
Yeah, it's been a combination. It's been a combination. Yeah, so it's been, yeah, a little bit of simulation for sure. It has helped, but it only goes so far. Actually, okay, I should be careful. The project we started like a year and a half ago. So a year and a half, it was too hard to make really good looking ones. I think that has changed. It's incredible. Again, as you were saying, how fast the industry is moving. It's amazing. Like the new simulators are becoming just incredible with ray tracing technology and all this stuff. It's just like unbelievable. So maybe I am wrong right now, but a year and a half ago, we used simulation, but it was just to start, and then we went and gathered a bunch of data, label it, and train it, and yeah, it was very tough. We had to iterate a lot. We released it. We didn't release it. We did an alpha test, and it didn't go well. We had to go back and train with more data. So yeah, it's definitely true. Everything people say, it's really about the data. You really are looking at things in the 500,000 to a million kind of like data points to ever come close to releasing anything like this. So it's and even then at this point at Avidbots we're about to release it, not quite there yet, but we're very soon. But again, it's really taking a while, and it's not that it still has like a few false positives, so it's not absolutely perfect. So it's really a lot of data, a lot of training, and yeah. But I do agree. I think simulation is going to play a much bigger role in the future. I'm pretty sure with all the new advances, it's looking really exciting.
Mm-hmm. Do you think, I guess simulation might limit this a little bit, but do you think that, so getting real data for something seems to be increasingly important for, I mean, like if you were going to make a Roomba competitor and you wanted it to avoid dog poop also, getting the data is something that's probably not feasible for a startup. Do you think that this, but kind of the need to have data is going to make a bigger moat around larger companies because they can acquire the data and make it harder for startups to become, I don't know, to gain traction in the robotic space in the near, I don't know, maybe like in the next 10 years or something like this? Do you think this would be feasible? I'm just thinking about it now. I haven't thought about it much before.
I think, yeah, you bring a very good point. I think yeah, the data is it matters a lot, and yes, you can do a lot with simulation, but
And it's
also
increasingly mattering too.
yeah, like exactly, because a lot of the computer vision algorithms are going towards deep learning, and in deep learning, that's the way to go. I do think there's a lot to be said though about like transfer learning. I mean, I think if, and that's again, that's oftentimes what startups are good at. They're younger people with kind of closer connection to the leading edge. So I think, yeah, transfer learning, simulation, maybe there are shortcuts they can take, but you are right. That's very hard to acquire. It is something that you need. Like we have a large fleet of over 200 robots plus in warehouses. Without that data, there's no way we would have been able to do this. So you're right. But I also think though, like I'm curious
I'm
about.
just wondering if it's going to get harder for startups to be like basically if you want to found a company in robotics now, I'm wondering if founding it in 10 years, founding a different company, because probably well the whole landscape will change. I wonder if it will become harder for robotics entrepreneurs in 10 years from now because of this kind of thing, because of the moat, because of the lack of resources for this kind of thing. Simulation might make up for it, but there's still going to be a lot of things most likely that simulation is not going to do well. Like I know contact forces or something that simulators have struggled with in the past, and so maybe there's other things too, and maybe those are being worked out, contact forces, but who knows? Or wet surfaces, or I don't know, whatever it might be. I'm just wondering, like really musing on this issue or this idea.
I'm also like, I guess just when you're saying startups in the future, um, I really hope, I don't know, again, not saying that Avidbots will be the one or somebody's gonna do it. I don't know who, but I think there's also something to be said about solving these problems finally. I think again, navigation in unstructured environments today is an unsolved problem. But 5 to 10 years from now, it's probably going to be solved. There will be a bit like, like it was, I do like a lot to read and study the computers in the 70s and also phones in the early 2000s. I think there's just tons of like overlap here. So yes, back in the 70s, you need a lot of money to make a NAR bridge, to have a memory management system, to have an I/O system for keyboards. It was like a nightmare, and it took like so much work. And there's all the startups doing it. Everybody had their own like architecture for a NAR bridge and for memory management. It's hilarious. Like the Commodore versus the Radio Shack one. They're all slightly different and doing the same thing anyway, which just like robots today, right? If you open up different AMRs, they all are going to be a little bit different, and like not you don't really need to be any different. So I wouldn't be surprised if like 5-10 years from now there is like a not I won't say off the shelf, but it will be a bit of a solved problem, like a kernel, like or like a mini ATX, yeah. Like here's the drivetrain, here's a bunch of sensors, just that's it, that's a robot. Just put it together, man. And here's the drivers that just work, and just like navigation is a solved problem. I don't. I will think it goes there. I will really think. I hope, because I think, and then that will make it really easy. Then, yeah, if you're a startup and you want to make a robot, a concierge robot, or a robot to, I don't know, help people in the hospital. I don't know what application you want. You don't have to worry about it, right? You just do your application. Yeah, exactly. You don't have to reinvent the wheel, and you could just go from there. Uh, I would think that's going to happen at some point.
Yeah. I don't know. I was just entertaining the new idea of it actually becoming more difficult, kind of being like a U-shaped curve for ease of doing a startup for this kind of thing. But let's see. For for your cleaning robot, for Neo, do you have any sort of like sensor that's evaluating how good you're doing at cleaning? Or is there like I don't know, how does all that work? And like what exactly are you doing with the cleaning? Is it having like a mop that it's bringing on the ground, or like a squeegee? Or what kind of thing for the actual cleaning?
Yeah, that's a good question. We are definitely investigating and research, basically, yeah, what we're calling it, I guess, floor cleanliness assessment. So to look at the floor and assess the quality of the cleaning. I think the problem is a bit kind of like multispectral though. There is a lot of other approaches. Like if you look at how iRobot does some of this, they count dust particles on the carpet, for example. That's one approach. There's also, I guess, some companies that are doing spectral analysis too. They have like a mini spectrometer checking the floor and then like assess, because again, pollutants might or might not be invisible as spectrum. They might look transparent, but it might be quite dirty. So yeah, so I think it's an interesting challenge. I think there's, again, a lot of ways to solve it, and it's something that we're investigating. We do, yeah, and I guess your question about cleaning. So we are basically trying to, again, our innovation is really more on the navigation and the autonomy. We are frankly using I would say we're following the industry best practices when it comes to cleaning. Like we're not innovating drastically in cleaning. That might change. We're investigating on ways to reduce water and improve the cleaning side. But we have so far Neo is very traditional. So the way it works is it's a floor scrubber. So it throws water in the front, and then there's these two pads that basically scrub the floor, and then there's a squeegee at the back that sucks up the water and puts it in a dirty water tank. That sounds very easy to say, very easy to explain like this, but I guess maybe that was one of the things that as a startup we struggled a lot with, is making a very reliable cleaning system. It sounds easy, but there's a lot of voodoo, there's a lot of details. To make a squeegee, for example, is tremendously complicated like mechanism. I know it looks just like a piece of metal, right? Whatever. It's not at all. It's so it's got roll, pitch, yaw, and you have to adjust all of it just right. And there's a lot of, and then you have to create a vacuum between the two squeegee blades that's just enough that produces good vacuum, not too much because then they're too depressed, and not too little so they're dangling in the air. So there's a lot of nuance. Yeah.
did you work with companies that manufacture these anyways? Or how did you like, did you design for your robot, did you design everything, including the cleaning mechanism from the ground up? Or did you like retrofit an existing cleaning company's platform or work with them to develop it? Or how did you get to Neo?
Yeah, so it is, yeah, it's a bit complex path. So in 2014, when we started, we did try and see if we could partner with these cleaning companies. Back then, when we were talking to them, they were not really interested. They were basically, a lot of them are established players that have networks and they had their own robotics initiatives, so they weren't interested in partnering with a small startup. Also, yes, I will say maybe we all thought in the team that it was easy. So I think we assumed wrong that it was a trivial thing to solve. And so, yeah, so we went ahead, we made design. So, yes, we design everything. So we own the design of the squeegee and the side squeegees and everything. It took a while, but I think we're happy now. I think we're at a really good place where we know what we were doing. We know, I would say we're on par with the best in the world. So that has really helped us when we sell because it's really a really good cleaning machine. Also, the other thing that we have that others don't have is, again, we have this obsession with reliability and quality. So our robot has sensors in each actuator, so we can predict when a certain part is not working properly, which is really powerful, right? Like imagine if you're cleaning and the squeegee falls off on a cleaning robot, a lot of our competitors just keeps driving and it just like throws water all over the floor. It's just horrible. But our robot has a camera that checks the squeegee is properly adjusted. It also has like this basically switches that detect that it's properly locked in, and it has an actuator measurement in the vacuum motor. So if the vacuum motor also starts to fail and not doing the amount of current that it's supposed to be doing, then we also flag it. So it's again really a bit like I guess Tesla floor scrubbers. Like we do like that data. Like we use that big data to predict failures a little bit, and so it's something that it's important. I mean, it's a robot. Again, this is where we drive our main differentiation is that it is a robot and it's smart and it has all these extra features. It's not just a manual machine with a brain on top. It is definitely a robot.
Yeah, and by doing the whole, like you have your whole vertical basically from like the manufacturer of the machine to its autonomy and its behavior and this kind of thing, which is really nice. That's a lot of control. Um, I don't know. I see that as being very desirable as a robotics company
It's,
to
it's,
have.
it's
Because
tough at the
if
beginning.
you go,
Yeah.
oh, I bet. Yeah, it's a big bucket of things to pour resources into for a long time, I imagine. How, actually, speaking of that, how are you guys funded? Or what's the business model around?
Yeah, so we basically we sell the robot. We do have direct sales where we also sell software. So when you buy a robot, you pay basically the upfront price is in the low 50s, and then you basically pay a $3,600 per year. Yeah, 52 that in that neighborhood, and then you're looking at basically also $3,600 a year for the software updates and the remote monitoring that I was describing, the remote assistance. So that's kind of that model. We also do have like a more of a rental model where you can rent a robot for 3 years to 5 years, and then we can change it like that. Yeah, and then again, we sell direct in a lot of jurisdictions, but in others we have distributors that service and sell a robot. For us, it's really important that we have a very good service for you because, yeah, again, it's an industrial piece of equipment. It needs to be maintained to be working properly and have reliability. That's again a very big thing at Avidbots. For funding, yeah, we have really good investors, really fortunate. We are, and again, we closed Series B a couple of years ago. We're about to close Series C. I cannot announce yet, but it's very, yeah, it's imminent, so it's definitely coming. And so,
Nice,
yeah,
congrats.
yeah, thank you. Thank you. It's good. It's been growing. I mean, I think again, there's a market, there's a need. People need this. It's been growing faster than anticipated as well. The adoption rates are accelerated due to the pandemic, uh, partially, and the reality is that they do work. The robots work. People are getting value from them, and so it's an industry that's being transformed, and it's very interesting to watch the transformation, like from fully manual to we're expecting to be 30% autonomous by basically 2025. That's basically every market analyst out there's yeah, between 25-30%.
Autonomous, like fully autonomous, and only. I thought earlier you were saying you were 80 something percent autonomous, or 80. So it's
Okay, sorry, yeah. So I did say so 80% autonomy. So that means that we have this 15% where either the human has to intervene or somebody else has to intervene. So I wouldn't claim that a robot runs 100% autonomous. I will never say that. It's just not real. That's what I meant by 87%, 89, 90%. Now, the adoption of so the transformation from the market that is basically trying to make sure I get you the right number going back in my head. So the entire global floor care equipment, it's I believe is in the. I'll have to get. It's exactly. So if you grab 100% of floor scrubbers, the floor scrubbers sold today is like close to 15 billion today. This floor scrubbers, just manual machines from 20 inches all the way to 36 inches, like the global industry of basically about $15 billion, growing at like a 3-4% CAGR. It's not super fast, but it's there. And so the basically that rate of automation is what I mean. That's really exciting because we were expecting, if you draw a straight line from zero back in 2013 to 25% in 2025, I would say we're actually above the line. Like we are seeing a lot of robots being sold in like the tens of thousands that we were not expecting to be at that number just yet. And so that's exciting. It's coming, and so that 25%. I know people were like, it's exaggerating. No way. No, like it's coming and it's there. Like it's actually happening, and yeah, it's so exciting. I don't know where it's gonna be, but it would be so cool. Like one day it's like 60-70% just robots. It's gonna happen. It's gonna happen, and it's just a matter of time. And so yeah, that's really our mission as a company. We want to be in the top three. That's our goal, and so it's a lot of work, a lot of hard work, a lot of competitors, a lot of very intense competition, and yeah, also it's awesome to it's great to watch. Yeah, like North America startups, Canada, and then China as well. China has a lot of action in robotics. It's incredible. I think we don't. I wonder. I it's just very. I'm very surprised, and it's very intense. They have a tremendous strategy with a lot of funding. The Chinese government gets very involved in robotics companies. They have a big stake in a lot of them, and lots of investment. I constantly see like the hedge fund of Shenzhen, 100 million to a startup. So in that size, so very very massive investments. So I'm curious. I worry sometimes between North America versus China. I just do see a lot more flow of capital in China from the Chinese government too, not just investors, but also that. So it's going to be interesting. I hope. I will say North America is pretty good right now, but I am curious who's going to win at the end because it's very exciting to watch this developments in China. It's very intense over there, very very active.
yeah. I wish I could learn more about what's going on in China. It's hard to find people to interview in China, so I'm not terribly aware. We did one with a smaller company, Mangdang, but and then I know like the Shenzhen area is very interesting, and there's a lot going on there, and they have a very closely integrated bunch of factories that do. It makes it very easy to produce a lot of things relatively, so they can try ideas quickly and get the hardware.
If you ever get a chance, like you should visit Shenzhen to the Huaqiangbei. It's called the main area for all the manufacturing. It's incredible. It's like a candy store for any engineer. If you're a hardware engineer, you're gonna. It's literally, dude. I felt like I could live there for like a week straight. Like just, it's you don't even want to get out. It's literally like there's a 45-story building on LEDs, and then the next one is resistors, the next one is capacitors, and the next one is cell phones, and it's just incredible. It's a very yeah. Very, very cool place. And again, super active in robotics. Super active in robotics. I would love. I haven't been in a few years. Is something I love to go check out. See what's going on in robotics there.
Yeah, for sure. I haven't been since COVID to China. I would love to make another trip as soon as the world calms down a little bit. Um, this kind of thing, and try to see what's going on over there. It's interesting. And then a lot of manufacturing of, I don't know, North American or European robotics companies happens in China. Where are you guys doing your manufacturing?
Yeah, we are doing it here in Ontario. So actually, we're lucky to be in southwestern Ontario. It's actually a pretty decent place for manufacturing. Uh, I know maybe it's not known too much outside of Canada, but Ontario, we're right at the limit with Detroit. So there's a lot of factories here that build parts for cars in Detroit, for GM, for Ford. We also have we have very large manufacturing here for Honda and Toyota for the whole of Canada, and it's actually like the only factory for Lexus outside of Japan. So very high end, high quality manufacturing happens here in Canada as well. So this is a good place. There's a lot of like small shops that know what they're doing, that can do steel, that can do machine shops and all this kind of thing. So it's a good place. I'm not gonna pretend that we're at the level of Shenzhen. We're not, but for kind of a small quantity reliability stuff, it's not a bad place.
It's like a Switzerland in a sense or something, very high end, smaller. Interesting. Yeah, I'm very interested in manufacturing in general, um, and how we can use technology to accelerate it and this kind of thing. So I'm looking forward to learning more in the future. I feel like so I'm in Texas now, and I think there's a lot of manufacturing that happens here. And I mean, in Austin, just a little bit away, there is like the Gigafactory and all sorts of things. But it seems like there's a good growing robotics scene down here, which I'm excited about. And I don't know. It's just we need places that are strong in manufacturing. I think to help us iterate through ideas, and because like, you need a quick feedback cycle where it has to be you have the idea, you know the parts, and then you get the manufactured and you try it. And keeping that time short, I think, is very very valuable.
Yeah, yeah. It's difficult to create ecosystems for sure. It's Yeah, China is just incredible, right? Like when I was there, you can find anybody to make you any part overnight if you wanted to. It's so intense. Everybody has a side shop, like a random engineer has a side shop doing CNC and here and there and 3D printing. They're always hustling, trying to do something new, and it's so alive. I don't think I've seen that level of aliveness on hardware outside of China. Not even. I mean, here is more like reliability and like bigger things. It's just nice too. It's a good place, but it's not that active. It's not that alive. Shenzhen is just intense. Like
How do you think it's changed with COVID over there? Because it seems like there's a lot of things slowing down with the zero COVID policy and these kinds of things. I don't know how.
sorry. Oh, sorry. Go ahead. Yeah, no, you're right. I would say yeah, it's been difficult even for us. Like we're researching some things to improve there, some suppliers, and it's been quite difficult. We cannot go right. It's like a 2 week you have to quarantine. But yeah, I think they're moving forward. They're still working. But yeah, for sure, it's been hit. It's been hit, and yeah, as you said, I look forward to the day where they remove that and we can go visit and spend some time and go back to normal a bit. Yeah, it'd be good.
Yeah, for sure. Yeah, I look forward to that. Um, let's see. What do you think? Actually, how are you guys working? Do you guys use open source software or you mentioned at the beginning you said you really liked open source software. Do you guys use it at Avidbots?
Yes, yes, we do use ROS. We don't use it to the depths that perhaps other people will use. We use it mainly for, I would say, yeah, the message passing, interprocess communication, for maybe some of the parameter stuff, some of the launch systems and the build systems. But that's basically where it ends. We developed our nav stack. We don't really use nav stack. We don't. Like a lot of the localization planning, all that's custom.
I'm not sure,
Um,
but I wonder if it would scale to 1 million foot warehouses.
yeah, I don't know. It's a bit complex. Yeah, I know actually I know people that use it even on big AMRs and big warehouses, but yeah, we don't. It's just maybe a timing thing. But no, I have definitely heard. Yeah, I've heard the global planner, like the global planner, the A-star stuff that is in Navstack. I've heard startups like in warehouses, million square feet warehouses, running the Navstack, like and move base and everything. And I was like, okay, I guess you like it. That's good. That's okay. We kind of had some issues with it, so we sort of did our own. But no, again, tremendous respect for SRF. Like it's been amazing. We are sponsoring actually. Finally, now we have a bit of cash. We are sponsoring we're gold sponsors of the ROSCON this year. Very happy to be doing that, giving back a little bit to the community for sure. Huge respect, and we do have a package. We made a 2D simulator called Flatland, and so yeah, we have it, and it's actually kind of active. It's got a few commits. It's just it's hustling a little bit. I wouldn't say it's taking off or replacing Gasiva or anything, but it is there and people use it. There's quite a few people that are using it, and we would like to try and see what we can do a bit more for sure. It's again huge fans. We are looking at ROS2 as well. Really interesting. NAP2 is a great effort. We love NAP2. We're considering also. That's pretty. That we might, yeah. Now we might actually jump ship because that's a pretty good architecture. It looks really robust and interesting. So it's something that we're looking into. So yeah, we really love Ross and really support it, and we'd like to get more involved hopefully in the near future.
Mm-hmm. Oh yeah, I love to hear that. That makes me happy. Let's see. So now where where do you think robotics? I guess actually we talked a little bit at the beginning, the like before we started recording. Can you tell me a bit more about the industries in robotics that you think are going to get that there is not very much attention on, but are very promising areas?
Yeah, I was mentioning that a little bit. Like I do think there's a lot of the early reports of market growth in robotics was all about the transportation and logistics, so AMRs in warehouses and that kind of thing. And yes, I mean it is by far, I would say yes, the biggest area. But I would say, just to give you some data that is interesting, and we certainly see that, is as of 2020, because of the pandemic and everything, uh, like transportation and logistics, they're like this is as per the World Robotics, the IFR like data points. Uh, Transportation and logistics are about 44,000 units a year, and cleaning and disinfection are about 34,000 units a year. So it's actually not that far. Like you wouldn't think that they're a second and a very close second, and then like medical robots are like 18,000 units, and then hospitality are 15,000 units. So there you go. That's like almost
What's a unit in this?
this is tens of thousands, so 34,000 units sold that year in 2020.
Hmm. Okay, so it's number of units sold in the industry. And that's what this metric is. So almost as many units are being sold.
I can put up maybe the slide, but it's 44,000 units sold in transportation and logistics, and 34,000 sold in professional cleaning and disinfection, and then
Yeah. So
18,000.
75%,
Exactly. And but I like the one about
50%, this kind
yeah,
of thing.
exactly. I like the one on hospitality that is 15,000 too. So it's not that far. Like things like delivery or other things like that are they're nobody talks about it though too much. And I do see, though, I guess China talking about it a lot more. I see a lot of robotics startups in China doing this, like basically delivery robots for uh, for restaurants, and also delivery robots for the big buildings. I see them delivering food as well. That's a very big application in China. Like WeChat, like when you buy something in China into your phone, like whatever, skip the dishes or something, or I don't know what you guys use in. in California or Texas, what it's called, but or DoorDash or something. Then the person drops it off to the robot, and then the robot goes to your office, which is pretty awesome, I would think. So you don't have to move, but yeah. So, but this kind of things is and I just think it's interesting data. I think we don't really hear enough about them, and I think it's definitely the worth noting that our applications that are, because there's so many sales, as there is an ROI, and there is an application there. So yeah, it is really exciting. I would say really the direction, as you were asking, I guess Avidbots, we really like cleaning. It's 34,000 units a year, so we certainly want to play in that field, but we also are firm believers that this is going to become multi-application. We believe that, so actually to give you a little bit of math, I think you're going to like the math here. So for example, we are doing the service of disinfection for $250 a month. So it's actually almost a tenth of the price. It's actually literally a tenth of the price. So if you were to basically do it, if you were to rent, or you were to have a human spray that thing for 3 hours, or you had a robot that was a disinfection robot, yeah, it's $2,500 to rent a robot a month. Any robot that is like about $40,000, it's going to come to about 2,500. So look at that. Look at the power of multi-application. You just attach something, and now you can deliver that with good margins for like tenth of the price. So I do think, again, this is definitely where it's going. Like you can have delivery, you can have a robot doing delivery, doing security, doing advertising. So it's becoming a bit like the computers in the 70s and phones in the 2000s, where basically this multi-application then really becomes very strong ROI, right? Because again, and not only that, but then other things become possible, right? Like you won't pay $2,500 for like a concierge robot in the front office to just sit there and smile. Like it's probably not very good either, because it's very, very hard to do a concierge. Like a robot that speaks to a human is a terribly difficult thing to do. But even if it was crappy though, if all you did it was just cool, but if you pay, but seriously, if you pay $300 a month, does it matter? Wouldn't you just pay because it's cool? Like, it just sits in the front office. Why not, right? So I think that's
Yeah,
going to be
like
very
if it's
interesting.
a freebie.
Exactly. Like you bought the platform, and then you just have all these applications, right? All these things that it can do, and so I really think that's where it's going. It's gonna. I hope it does, because it really then it really, the value is just much more, right? That's how I will hope that we get to the $1 trillion, to the hundreds of thousands of units a year sold, when you really when it's just so compelling. Like, and yeah, again, if you look at a little bit about computers as well, it was kind of like that, where there was like this killer app, right? Like the VC-Cal for computers in the 70s, but then you could also run like Prince of Persia, exactly, the spreadsheet app. So that's the reason why you bought the computer, because you can maybe do like, I don't know, some basic things on it and print and stuff. But then you could also, like, I don't know, play Doom, or you can play Prince of Persia. You can start doing all these side things that then that's how computers moved from like the office to the house. That's why people started being like, okay, I'll buy that. That sounds cool. Like it starts to make sense. It starts to really multiply and deliver a lot of value. That's ultimately really why people are buying these things. So that's where we do think that's where it's going to go, and really exciting, because just more robots everywhere. That's the dream, I guess, the vision.
The hope, yeah. Yeah. I see this as like a big trend in robotics, which is interesting. I kind of, just as you point out, where it's moving into adjacent tasks that you can do cheaply with the same hardware. Like you have that one killer application. So for yours, it's cleaning. And then after that, you can add like a little spritzer that does disinfectant. Or I wonder, be a security guard robot and patrol the warehouses, just drive around, this kind of thing in the off hours, or whatever it might be. Like I'm thinking Cobalt Robotics, they have their security guard robots. That's their core offering. They're also thinking like HR robot, not HR, but like show you to the meeting room if you're a guest of the space, like office guide or something.
this kind of thing. It's like you already have the robot there. Oh, and then they also do environmental monitoring in the inside of the building, so you can tell if a bunch of cold air is leaking in through the window or something like this. It's like those are little add-ons that you can do that are basically free because it's needed to complete your core function. And then otherwise, they're just added value to the customer at very little cost to you. So it's like moving into adjacent things. Very cool. Yeah.
Hopefully, I think it's where it's gonna go. So it's really exciting.
Hmm. Yeah, very, very cool. That's a really cool pattern to make explicit. Um, like moving into adjacent industries with the same hardware. And like also Canvas, who does drywalls, also does sanding because it's an adjacent thing, and they're starting to do more of those adjacent tasks because they basically have the hardware already. This kind of thing. It's quite cool. Um, so we're running up against your hard time limit. Um, do you have any advice for people who want to be robotics entrepreneurs?
Hmm. Uh, yeah, I do think. Hmm. Um, I guess there's a few publications that say that is the decathlon of startups to do robotics, and I will agree. I think robotics, if anything, it's very tough because you have to get a lot of things right. You have manufacturing, you have web development, you have the autonomy side, and you have the hardware side, which is the electronics and the mechanical. And so it's a very wide spectrum. So I think yeah, that's definitely tough and not as easy as other potential startups. But at the same time, again, it's a tremendous time in robotics. I think we're right at this beautiful early beginnings of this exponential growth. So I think there's a lot of opportunity. It's definitely going to expand a lot. I think probably more than a lot of people expect. Um, because again, yeah, like a lot of the long-term reports are all based on logistics and transportation. There's other things out there. There's other applications that are not on the radar that are really there. And yeah, it's tremendously exciting to watch all these startups. I do see a few from China again in like 3-5 years. They're like in the thousands of units. So that's a testament really to the fact that it is here. The technology is here. That much we know. So we're not trying to make a phone in the 70s like this or a smartphone in the 70s. This is a thing. Like the timing of technology was right. I do think cultural adoption is getting much better. I hope we all, do good, safe robots that, really make people happy and stuff. And so it really is that economic impetus. So I will say that the big thing I will also, yeah, certainly to be aware is that, yeah, to pay a lot of attention to the business side. I do see a lot of robotics companies to go love making $100,000 robot that has like a 1 hour savings per day. So the ROI is not really there. I think it's really easy to do that. It's really easy to over design it and to forget about really the ROI and how the customer is going to use it. So I think that's a very important. I'd encourage people to really pay attention to your ROI and to your economics, to your unit economics, and to really make sure that you're building something that has that economic impetus and that ROI and that value. I think that's pretty important. Um, yeah, I would say, yeah, if anything, advice would be to do it. I guess if I can plug in the thing, I think Canada is a great place too. Yeah, sorry, I know you're from Texas and OSRF is in the US. I know, but I have to say I do think Canada is a good place. I think it's something to consider for entrepreneurs as a country. It is nice. I mean, our salaries here are lower. Is almost there is an equation I can show you the article. Almost 2.5 times cheaper in terms of salaries and office space. Like office space here is a lot cheaper, and salaries are also lower. And so
Is it compared to like the Bay, like the San Francisco area, or
yeah,
is that compared to like the middle of? Oh, okay. Well, I mean, they're incredibly expensive over there. Yeah.
you're right. Yeah,
I mean, I have a
yeah.
house
You
for
got me there.
my
You got me
mortgage on
there
my
for
house
sure.
is what my rent was.
That's right. Yeah, so sure, yes, I am comparing it to Silicon Valley, but again, also it's just like again, there's a lot of talent here. The manufacturing here is good. There's a lot of shops. I think is an interesting place to consider. It's an interesting place to consider. And yeah, and then, as you said, I hope we do end up building meccas of robotics and big ecosystems. And yeah, I hope we let's see that the race is up with other countries. So I hope we, at least in North America, I don't really mind if it's US or Canada, but I hope, yeah, Europe also has very good startups too. I hope North America ends up being like the main place for robotics. I think we can. I think the certainly the academic institutions are here, but are we gonna maintain the industrial leadership? I hope we do. It's gonna be tough for sure, because China's ramping up pretty good. That's for sure. So let's see how it goes. Looking forward to hopefully keeping it here, the big meccas of robotics.
For sure. Let's see. Do you have any links or contact information that you'd like to share with our watchers and listeners?
Sure. Yeah, I can send you, I guess, my email, LinkedIn as well. You can contact me there. I'll be happy to answer any questions, help anybody. I can give a little tips of things that I wish I knew when we started. I think it can save people a lot of time. I've made a lot of mistakes that you don't have to make again. So.
How funny. Okay. Well, hell yeah.
Awesome. Sweet. No, greatly appreciate again the opportunity to talk. Really fun. You're very knowledgeable. I love talking to people with this depth. So that was refreshing. That was pretty good. And yeah, I greatly enjoy it. So thank you for your time and the opportunity. It was pretty fun.
Thank you. I enjoyed it as well.